With the base 10 system, two characteristics must be understood in order to understand this place value system. The first characteristic is to interpret the place value of the number, and the second is to interpret its face value. So the best way to actually deepen this understanding is to use an example. So let's go ahead and direct our attention to this week's financial news. As we look at the debt clock for the United States, let's go down to the savings per family here. This one is, at this point, it's pretty constant, so we're just going to use it a little bit as our example so that we can understand two characteristics about the base 10 system. Okay, so if you look here, the 9 in the 97, okay, it has a place value representing the tens place. The place value of the 9 must therefore be interpreted to mean that 9 groups of 10, not 9 ones, are being considered. And the 7, this last 7 over here, so 97, the 7 means 7 ones. So let's head over and look at our place values. So at the top here you can see our place values. Okay, so we're working in whole numbers only, so from the left side of the decimal here. Okay, this first place represents ones. The second place represents tens, then hundreds, then we have thousands, 10,000s, 100,000s, millions, 10 millions, 100 millions, billions, 10 billions, 100 billions, and the list goes on. Okay, so at this point we're using the 97 in the savings per family number, just the 97, to kind of understand, get an idea about what the place value means and the groupings by 10. All right, so the 9 represents the tens place and the 7 represents the ones place. Okay, so what that really is 9 tens, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 10 plus 10 plus 10 plus 10, all the way over up 9 times. And then the 7 represents the one place, so there's 7 ones. 1, 2, 3, 4, 5, 6, 7 ones. Okay, and you add those all together and you're going to get the 97. All right, so that's what it's talking about when it's talking about the place value and the face value of the base 10 system. All right, using our same example, 7, 8, 9, 7, let's look at the 8. The 8 falls under the hundredths place. So what that means is there are 8 100s. We're adding together 8 of these 100s. Okay, and so then looking at this first 7 here, that falls in the thousandths place value. Okay, so what that represents is 7 1,000s. So you add 7 1,000s together. Okay, so if you add all of these up, you come to 7897. So 7,897. So organizing each of these numbers into its specific size groups, then you can realize now that that's how you can count these groups. Well, so far we've examined place value concepts using quantities greater than 1. Well, grouping in base 10, it allows us to represent larger quantities efficiently and with only a few symbols, but what about when we have to represent quantities less than 1? How do we apply the ideas of groups of 10 with smaller quantities? So let's look at the place value chart again. What I've done is I've extended it now from the decimal point all the way to the right, okay? And I didn't go, I mean, obviously it's going to go to infinity, but I just wanted to go out some of the normal lengths of decimal places that you will see. All right, so what I've got here is you'll see that anything to the right of the decimal is going to represent a fractured whole, okay? Basically, if you have one item and you want to share it, you're going to have to fracture that whole into lots of different pieces depending upon how many people that you have, right? Or how many things you want to share, okay? So that's why you'll see a fractured 1 here, and then it's showing you to the right is the fractured whole, okay? So this will sink in a little bit as I go through this little bit of an illustration for you. All right, so to represent a quantity that's less than 1, okay, we need to fracture a whole. So I have a picture here. It's think of this as, oh, how about a Hershey's bar, okay? This whole thing here is one big whole Hershey's bar. Well, what if I wanted to share this Hershey's bar with a person, with other people, right? I didn't want to eat the whole thing. I want to share some of it, okay? Let's say I have 10, there's 10 people, so I have 9 other friends that I want to share this with, okay? Well, I'm going to I'm going to fracture this whole into 10 pieces. So I'll take a piece, and then I'll give a piece to each of my 9 other friends, okay? Now, how we represent this in fraction form is the numerator, which is the top number, okay, is going to represent how many pieces exist. And then the denominator is going to represent how many pieces make that whole. Okay, so for example, let's say I have this, we'll use the same Hershey's bar as an example. All right, at this point, let's just say I ate 9 of those pieces and I have 1 left. Well, that 1 that is left is going to represent 1/10, right? Because it's split into 10 pieces. 10 pieces at this point make up this whole Hershey's bar. I ate 9 of them, and there's only 1 left, so 1/10 is remaining. So to represent what I ate, it would be 9/10, right? Because 9/10 are missing. So then this would be a 9/10, showing that 9 are what I ate, and then 10 is what how many pieces it was actually broken up into. So for this numerator, it's basically what do you want it to represent. So if I wanted to say, well, how many pieces did I eat, or how many are missing, I would say 9 on the top, okay, because that's what I want to represent, 9, and then 10 is what it took to make up a whole. So this would be 10/10, showing that there's a whole, right? Because 10 divided by 10 is 1. Okay, so let's talk about this in the sense that of our numeration system, okay? In our numeration system, we're going to divide the groups by 10, or partition. That's another way of saying divide, break up, okay? We're going to divide those groups by 10 when we want to represent quantities less than 1, okay? So I have here showing you, so 1 divided by 10, so we have our whole, and we divide that by 10, that's going to get us to the tenths column, place value here, okay? If we divide that again, so we're going to take then that tenths, and then we're going to divide it by 10, that's going to get us to the hundredths, and so forth. So then you take the hundredths, divide it by 10, it's going to get you thousands, take the thousands, divide it by 10, you're going to get 10,000s, take 10,000s, divide it by 10, you're going to get 100,000s, and on and on and on, okay? So this place value system, you'll see that it's going to basically represent kind of how it lists over in the whole, right? It goes from tens, hundreds, thousands, 10,000s, 100,000s, right? So then it's going to keep going from there. Okay, so now let's look at this as an example. Okay, so let's say we have 5 square pastries that we want to share evenly with 4 people, all right? Well, how much will each person receive? So I'm going to use squares to represent the pastry, okay? All right, so we have 5 pastries, so we're going to have 5 squares, all right? And we want to share evenly with 4 people, all right? Well, right away you can see that each person's going to receive a full brownie, right here, and that's going to leave us with 1 brownie left over, okay? So to follow our dividing rules, right, based upon our numeration system, all right, we need to cut this brownie into 10 equal pieces, and we're going to call those tenths, right? All right, so now we've got those that one whole broken into 10 pieces, and we're going to call these, and so these now are tenths, okay? So remember, there's a total of 10 pieces, and one of them will represent 1/10, okay? So now we have 4 people. We can distribute 2 of these tenths to each person, okay? So each person is going to get 2 tenths, and that's going to leave us with 2 tenths left, right? Because we can't give them any more because we don't have enough here. We're going to have to, again, fracture this to get, break it into more pieces so that we can continue dividing this up. So what we're going to do is we're going to divide the 2/10 by 10. And so that's going to give us 20 pieces. And each of those pieces, now we've moved over another decimal place, each of those pieces represent 1/100th of the original square. Okay? So now we have 20 pieces, and what we can do is distribute evenly 5/100ths. So there's each of these little squares now represents hundredths. Okay, so it's a 1/100th. So we're going to give 5 1/100ths to this person, 5 1/100ths to the second person, 5 1/100ths to the third person, and 5 1/100ths to the fourth person. As you see, that actually now there's going to be none left. There are no leftovers after we divide these hundredths up evenly between the 4 people. Okay, so we can represent this here. Remember, now we had each person got 1 whole, so that's 1, right? 1.0 is 1. And then each person got 2/10, right? Because we took that whole and we broke it up. We divided that by 10, which gave us tenths. So each person then got 2 of those tenths, okay? And then that is represented by 0.2. Because 2 divided by 10, 2/10, right? 2 divided by 10 is going to give you 0.2. All right, and so then we had 2 left over. So we had to again divide that by 10, which gave us hundredths. Okay, so you took 0.2 and you divided it by 10 and you got 0.02. Okay, so let's look at this concept in practice. If we have 5 square pastries that we want to share evenly with 4 people, how much will each person receive? Okay, well, we can represent the pastries with squares. I'm just going to keep it pretty simple. Okay, all right, so here are 5 square pastries. All right, we want to share these 5 pastries evenly with 4 people. Well, right away, you know, each person's going to get 1 whole pastry. Okay, so we have this 1 left over then. So to determine the part of 1 brownie, let's look at this concept in practice. All right, what if we had 5 square pastries that we wanted to share evenly with 4 people? Well, how much will each person get? Well, we can represent the pastry with squares. So I made it a little simple here. So I have just 5 brown squares to represent our square pastries, okay? Well, right away we can see that each of these people, they can get 1 whole pastry, okay? Well, that's going to leave 1 left over that we're going to have to break up. Okay, so let's look at this concept in practice. What if we have 5 square pastries that we want to share evenly with 4 people? Well, how much will each person get? Well, we can represent the pastry with squares, and I have 5 brown squares here to represent those pastries, okay? Make believe they're chocolate squares. So you can see here that right away, each of these people are going to get 1 whole one, okay? Well, that's going to leave us with 1 left over. So to determine the part that one pastry to determine the part of the 1 pastry that each person will get, we must follow the dividing rule, right? Based on that numeration system that I just went over a little bit ago. We need to cut that pastry into 10 equal pieces called tenths, okay? So we're going to distribute 2 of these tenths to each person. So when we cut that into tenths, that created 10 little pieces, okay? Made them smaller. Because remember, we took this piece here and we cut it into 10 little pieces. All right. So we're going to distribute 2 of these tenths to each person, leaving 2 pieces left over. Okay, so this each piece again represents 1/10, and so we have 2/10 left over because we gave each of these people 2/10. Okay. Well, following the dividing rules again, we have to cut the 2/10 into 10 pieces each. All right, so that's going to give us 20 pieces. So now we have 20 pieces. Each piece represents one. All right, so following the dividing rules again, right, we're going to cut the 2/10 into 10 pieces each. So now we have 20 pieces. So each piece represents 1/100th of the original square. Okay, so you can tell it's getting smaller and smaller and smaller every time we divide, right? All right, so we can take these 20 1/100ths and we can distribute these evenly to 4 people, right? Because there's 20 pieces here. There's 4 people. Each is going to get 5/100ths. Okay, so 5 of these little squares is going to go to each person, and there aren't going to be any more leftovers. All right, so there isn't going to be any more leftovers after we distribute these 20 pieces to the 4 people. All right. Now, if you're in a situation that you have to keep cutting the leftovers and the process never ends, well, this is what a repeating decimal is all about. All right. So repeating decimals, those result when there are leftovers from dividing the process no matter how many times you divide. And so you'll see that, so like pi would represent a repeating decimal. You cannot represent that in fractional form because it never stops. It keeps going forever. Okay. So, all right, delete that last pi part. Okay, so this should help you understand. What it means to have a fraction, right? It's just a fractured whole because we wanted to share one whole piece or one whole item with others. Okay. Kind of just a representation of that. That's kind of how it all started. So we want to just take that one whole and fracture it into pieces, and we have to keep fracturing if there's still leftovers based on our numeration system. All right, well that concludes this video.